Pre-statistics. Solving more linear equations and one variable. Lesson objectives. Solve one variable linear equations and check their solutions. Solve one variable linear equations involving fractions by multiplying by the least common multiple. Lesson objective number 1. These are the rules for solving a linear equation. Number 1. We want to simplify the algebraic expression. So if we have any like terms, we want to combine them. Number 2, we want to collect all the variable terms on one side of the equation. Number 3, isolate the variable and solve. Number 4, we check the proposed solution in the original equation and we want to see, does the left hand side equal the right hand side. Let's do an example. We have 2x minus 3 equals 5. So if you recall, we want to isolate the variable. We want to get x by itself. We need to get rid of the 2 and we need to get rid of the 3. Now this is the first case where we have two operations, and the question is what do we do first? Well, let's look at a visual. So we take our variable x, we multiply by 2 and we get a number, and then we take that number and we subtract 3 and we get a number 5. Now solving equations, we're going to follow the order of operation backwards. So the last thing that we did, minus 3, is going to be the first thing that we unravel. So the opposite of subtract 3 is to add 3. Then the next step is we have to undo multiplying by 2, which is of course divide by 2. So when solving equations, we always want to follow the order of operation backwards and in reverse order. So let's solve this one. Our first step is to add 3 to both sides of the equal sign. That leaves us with 2x minus 8. Now to get rid of the 2, we do the opposite, divide by 2, and we have x is equal to 4. To check this, we start with the original equation. We substitute our solution 4 in for the expression on the left hand side, and if this is correct, it should be equal to what's on the right hand side, 5. So we have 8 minus 3, which is 5. This gives us a true statement, therefore 4 is a solution. Example 2. Let's look at a visual. So our first step is we're going to take x and we're going to add 5. Then for that number, we're going to multiply by 8. And then our last step is we divide that by negative 3. So to unravel this equation, we are first going to start with our last step of the order of operation. We're going to multiply by negative 3. Then our next step is to do the opposite of multiply by 8, which is to divide. And then our last step is we're going to subtract 5. So our first step is to cancel out the negative 3. Since it's dividing, we do the opposite and multiply. And if we do it to the left hand side of the equation, we have to do it to the right hand side. The negative 3's cancel. We're left with 8 times x plus 5 equals negative 48. We could distribute, but we can also divide. So the 8's cancel. Negative 48 divided by 8 is negative 6. And lastly, we want to minus 5. And that leaves us with x is equal to negative 11. To check it, we're going to take negative 11, substitute it in for x. And what we hope is the left hand side will equal the right hand side, 16. Order of operations, we have to do parentheses first. Negative 11 plus 5 is negative 6. That's being multiplied by 8, then divided by negative 3. Next we multiply. 8 times negative 6 is a negative 48, divided by negative 3. Negative 48 divided by negative 3 is 16, and the left hand side equals the right hand side, so it checks. Example 3. In this example, we first want to combine like terms. So we want to take 4x and subtract 7x, which gives us a negative 3x. Our next step is we want to get rid of the 2. Since it's adding, we do the opposite and subtract. These cancel here. This side of the equation will become 15. Lastly, to get rid of the negative 3, we do the opposite of multiply, which is to divide. So we divide both sides by negative 3, and x is equal to negative 5. To check this, everywhere we see an x, we're going to substitute negative 5. And what we hope is the left-hand side equals the right-hand side. The right-hand side is 17. So here we have 4 times negative 5, which is negative 20. We can think of this as negative 7 times negative 5, which is positive 35, plus 2. Does that equal 17? Negative 20 plus 35 is 15, plus 2, and we know that equals 17. So 17 equals 17. The left-hand side equals the right-hand side. Example 4. Here we have an equation that has variables on both sides. So our first step is we need to move the variables all on one side of the equal sign. It doesn't matter if it's the left-hand side or the right-hand side. For this example, I'm going to move the 2x to the left-hand side. Now, in order to move this variable term, I need to subtract 2x to this side, and then I will subtract 2x to this side. These are now like terms. Negative x plus negative 2x becomes negative 3x, plus 7 equals negative 2. The next step is we want to cancel out the plus 7, so we subtract 7 to both sides. That leaves us with negative 3x equals negative 9. And of course divide by negative 3, and we get x is equal to a positive 3. To check it, everywhere we see an x, we're going to stick positive 3. And what we hope is the left-hand side will equal the right-hand side. Following the order of operation here, negative 1 times 3 is a negative 3, plus 7, which gives us 4. On this side, we multiply first. We get 6 minus 2, and of course that's 4. So we have the left-hand side equal to the right-hand side. It is correct. Example 5. Our first step is going to use the distributive property both on the left-hand side and the right-hand side. So we have negative 2a plus 6 plus 4 equals 4a minus 8. Combine like terms here, and we get 10. We have variables on both sides of the equal sign. We could add 2a to both sides, or we could subtract 4a to both sides. It doesn't matter. I'm going to subtract 4a to both sides. Combine like terms. We get negative 6a plus 10 equals negative 8. Next step is to subtract 10. And then finally we divide by negative 6, and we get a to be equal to 3. To check it, we substitute 3 in for a. Hopefully the left-hand side will equal the right-hand side. Order of operations, 3 minus 3 is 0, times negative 2 is 0, plus 4 is 4, and 3 minus 2 is 1. We're left with 4 equals 4. This is a true statement. 3 is the solution. Example 6. Our first step is to combine like terms. We have 4x and 2x. That becomes 6x minus 14. In this case, we have 6x and 4x on this side of the equal sign becomes 10x plus 2. Now we have variables on both sides. This time I'm going to subtract 6x, cancel this term out. But if I subtract 6x to the left-hand side, I have to do the right-hand side. We're left with negative 14 equals 4x plus 2. Subtract 2 to both sides. Left with negative 16 equals 4x. And when we divide by 4, we see that the answer is negative 4. Now to check it, I'm going to use the calculator. What you want to do is you want to put in the expression on the left-hand side and then put in the expression for the right-hand side, and hopefully they will equal. So for this expression, this is going to be 4 times negative 4 minus 14 plus 2 times negative 4. That gives us negative 38. For the right-hand side, 6 times negative 4 plus 2 plus 4 times negative 4 is negative 38. The left-hand side equals the right-hand side. Therefore, negative 4 is the solution. Thanks for watching.